Hi, my name is Therese. Researchers all over the world are using innovative, state-of-the-art methods to measure microlitter. And thanks to this, we know today that our current consumption patterns leave global, widespread traces. But we're also seeing a rising global will to change this. And we're asked, what can we do? My colleagues on the second part will go deeper into different solutions that we have for these problems. But I've also found that this question actually puts a spotlight on a few of the current gaps in the knowledge that we have. Such as, how much is there? How much is it over here compared to here? What kind is there? And is it different now from 2 years ago? We can get an estimate from the data that we have already collected so far. But in order to answer these questions more in depth, we need to be able to do more precise measurements. And we want to answer these questions in order to create baseline values, to make risk assessments, and also to start mapping out sources. So within the CleanSea project, we've been working with different method developments. And we wanted to start at the start with sampling. So we created this pump. It's a filter system with different kinds of filters, with different sizes to look at microlitter. With this pump, our thinking was that we wanted to get a precise measurement of volume. We also wanted to minimize microlitter loss and avoid contamination, so all parts are made in metal. Additionally, we wanted to be able to measure at different depths, looking at different sizes. As you understand, these are a lot of requests to put on one sampling device. And we've had a few bumps on the road, or rather at sea. But our final tests show really good, Our final tests show good result for these methods. And it also shows that we seem to get slightly higher results when using this pump compared to traditional methods such as trawling. So once we've sampled, we needed methods for extracting the microlitter. And as you've already heard, microlitter is a very diverse material. It comes in different shapes, sizes, densities. So we wanted to be able to look at different environmental matrices, including sediment and biota. So we've tested a set of different kinds of methods, and we found that below 300 micrometers, which is tiny, it became harder and harder to actually recover all of the microlitter if we put in to test our methods. But through testing these different methods, we found ways to get good recoveries and to avoid contamination. And sometimes the solutions were really technical. Sometimes it was enough to just add 1 drop of olive oil. Then we reached one crucial step, identification. The first time that I was going to measure a sample, I got a microscope and I sat down and I was told, just count the plastic. The samples could look something like this. Of course, with time, you learn that the way that the breaking points look or the way that the fiber coils can tell you so much about the material. But I probably had to redo my first 10 samples or so. And today, if I compare to a colleague, our counts will still differ. Because of this, it's becoming increasingly common to couple visual identification with spectroscopic identification. This is still done on a particle-by-particle basis. And we wanted to see if we could tie a little bit different take on it. So we would use hyperspectral imaging. The principle of this is that we took our samples, we put it in a special kind of camera. From this camera, you get a picture with an X and a Y axis and a certain set of pixels. For each pixel, you also got a spectra. Through comparing this spectra to different references, we can then say what kind of material is within that pixel in our image. This generates huge sets of data. So in order to manage this, we would use different statistics methods and multivariate data analysis. What you see here behind me is a PCA plot which shows you the clustering and the grouping of different kinds of material. And this would create a more objective and kind of semi-automatic way of measuring microlitter. In our setup for this method, we would use a 300 micrometers as the lower size limit. But in reality, the limitations of this is mostly based on what kind of spatial and what kind of spectral resolution that you have. So you could zoom in and look at smaller pieces in a smaller area, or you could zoom out and you could look at bigger pieces in a larger area. While we've been testing all of these methods, we've learned a few things and had a few things confirmed about microlitter. One is, it's a very diverse material. And this is really important to keep in mind when you're designing your research question or your experiment, because there's no perfect method. For example, there are still size fractions that we can't quantify. And even for the kinds of litter that we can quantify, there's no one-size-fits-all method. And for whatever method you choose, it's important to assess both the contamination and the recovery of microlitter. We have also, through looking at these different methods, realized that we are likely still underestimating the amounts of microlitter in the ocean, especially since there are still fractions and particles that we just can't measure yet.
Thank you very much.